Well, let's talk about transformations of functions. And what we're really going to do is start with a certain function called a parent function, and then we're going to find out what happens to it to get the other function. So the parent function in this case is going to be f of x, and the child, we don't use that phrase necessarily, even though we do have a parent, we have the child, that's g of x. So we're going to look at f and see what we did to get g. Okay, and we're just going to use some vocabulary like horizontal shift, vertical shift, stretch, shrink, things like that. Reflection around an axis, stuff along those lines. And we'll just kind of see what happens. So if I started here, and this is the parent function, and I want to know how to get this one, then I would say, well, it looks like also a parabola, and it looks like it had a shift of up 3. So vertical shift. So I'm going to write vertical. You can abbreviate that, VERT, if you want to. Vertical shift of positive 3. And that's the only thing that's happened to it. Excuse me. That's all that's happened. So now we're going to go over here to the second one, and we're going to look at the parent and then the child, the offspring. And again, we don't necessarily use the word child or offspring when dealing with math, but there is a parent function, and more than likely you look somewhat like one or both of your parents. So this should look like this, and we should be able to say what qualities it has. Well, both the parabola and that kind of thing. So from this function to this function, it looks like we slid this thing over from 0 to 1, 2, 3. So a horizontal shift. So horizontal shift of 3, and I'm going to say that's positive 3. And actually, even though it might look like that's the only thing that happened, it's not. There's one other really obscure thing that happened, and it has to do with looking at the skinniness, narrowness, or wideness of these parabolas. So here's the original, here's the parent function, and then here's the other one. Is this skinnier, or is it wider, or is it the same as the parent? And I'm going to go ahead and say that it's skinnier. So I'm going to call this a vertical stretch. And this vertical stretch is, well, I don't know. Let's see what the stretch factor would be. Okay, so I'm going to grab a pencil and I'm going to just point at a point. Here's a coordinate on the original parent function, and it was at 1, 1. So on the other function, going from the vertex, if I went to the right 1 and went up 1, I wouldn't be on the actual function. See, this would be like to the right 1 and up 1. Now to the right 1 and up, oh, have to go 2. So my vertical stretch took every coordinate and stretched it by a factor of 2. So vertical stretch with a factor of 2. I can't say plus 2 or minus 2 or anything. It's not a shift in terms of like sliding something, but it is a stretch in terms of having a scaling factor. Okay, let's go to the next one. Well, here's the parent, here's the child. What happened? I started here, I ended here. So where did it move? Let's find out. So I think it moved 1, 2, 3. We'll say that. So horizontal shift of positive 3. Okay, so it went 3. It also moved up 1. So I'm just looking at the vertex right now. So vertical shift of positive 1, and I've ignored one of the most obvious things that happened was that my parabola was like this, and then it turned upside down, and we call that a reflection. It is reflected around an axis. Now, if you look at the one below it, you'll see that here's the original and here's the child. Here's the parent. Here's the one that's been modified or transformed. And this one is reflected around the y-axis. This one, on the other hand, is reflected around the x-axis, and it may not look like it, but here's what really happened. So here was my original function, and then I said, you know what? Let's transform this thing, and we're going to just reflect it around the x-axis. Reflect it about the x-axis. Either one of those words is used. Now, in addition to that, we also slid it to the right, and we also slid it up 1. Let me use proper mathematical terms. We translated it to the right 3. We translated it up 1, and there's one other thing also. So we've done a horizontal shift of 3, vertical shift of 1, a reflection over the x-axis, in addition to so many other things. We probably did that first. Like if we're going to order what we did, we'd flip it over the x-axis first, reflect it, let me use the proper language. And there's one other thing that's really obscure, and it's the same thing we did here that was very obscure. Notice that this one is normal width. This one is just a little bit skinnier. This is normal width, and because it's moved and in a different place, it doesn't look the same, but it's actually skinnier. And this is also a vertical stretch. And the scale factor is also 2, and just in case you need to see it. So if I went over 1 and up 1, fine. Starting from the vertex, I'd go over 1 and down, because it got flipped over, got reflected. So over 1 and down 2 before I actually hit the function itself. So a vertical stretch of 2. So scale factor of 2. Okay, so we've gotten a little bit of vocabulary taken care of, just kind of looking at it, identifying it, and seeing what's going on. So let's keep moving, and this will speed up just a little bit. Here's the parent function, and here is the one that has had some modifications to it. Well, it started at the origin, the other one starts at the origin, so there's no horizontal shift, no vertical shift, but I do see a vertical stretch. So the coordinate 1, 1 is a coordinate on the original function. The coordinate 1, 1, 2, 3 is a coordinate on the transformed function. So this one has a vertical stretch of 3. So we're multiplying by 3. Okay, we'll do the same thing here. This one actually is also a vertical stretch of 3. You can kind of look at them side by side and tell that. And another way is you could say, well, from the beginning point, I'd move over 1 and up 1. From the beginning point here, I'd move over 1 and up 3. So same thing, vertical stretch, vertical stretch. So I put an extra C in that word, stretch, there we go, of 3. But there's something else that happened, and that thing that happened is a horizontal shift that went back 1. So horizontal shift of -1. So notice the vocabulary. If I am sliding something around, then it's actually called a translation. Altogether, these are called transformations, but a translation is a shift. And we'll get the vocabulary sorted out in a minute. We've already dealt with this one. They are the same vertical stretchness. bad choice of words there. But in this case, what I really have is just a function that got reflected over an axis. So this is a reflection over not the x-axis, but it's actually over the y-axis. So what was over here is now over here. So this is a reflection over the y-axis, and there's a way to accomplish that with an equation. We'll deal with that on the other side of these notes. Okay, here goes. Same thing, actually, same function. So there is a reflection over the y-axis, and there's one other thing that happened. So it got reflected over. I shouldn't say flipped, I should say reflected. And not only did it get reflected over, it also slid. Let's use mathematical language. It was translated down 4. So 1, 2, 3, 4. And when I say down 4, that's vertical. So we're going to say this is a vertical shift of -4. Okay? Running out of space on that one. Okay, original function is this, and it's actually this piece on the other side too. I'll kind of outline it in blue there, in case you need to see it. And then the function that has had the transformations is that one. So, the original is the blue, the one that's been transformed is the red, and there is no shifting. The vertex is in the same place. It didn't go up, didn't go down, it didn't slide around. It's just none of the translations, no shifting. It's not been reflected over anything. The original function is kind of a reflection of itself over the y-axis. Nevertheless, there is a vertical, I use this term very loosely, vertical stretch, and I'm going to go ahead and write vertical. I'm going to call it a vertical shrink, actually. And what I really did was I took the f function and I made it half as tall as it was. So my shrink factor is 1/2. So my vertical shrink, basically I scaled it by a scale of 1/2. And if you don't know where that came from, look here. So that's at the coordinate 1, 1. Well, now it's at 1, 1/2. Or 2, 2 became 2, 1. So it's half of what it was. Okay? So we're going to do something similar here. This one, the original, is up above the x-axis. So there's f. And then the transformed function is down here. It's that one. Okay, well, what happened? Well, you got a glare on your table. That's what happened. The lamp's too bright. There, I'll slide this over so there's not a glare. But a couple things have happened. First of all, one thing that happened was that all your graph was up here, and then it got flipped down. So let's not say flipped. Let's say reflected. It's a reflection over which axis? Well, it went from up here to down here, so it's going to be over the x-axis. And not only that, it got skinnier. That sounds like a vertical stretch to me, so vertical stretch. Now, at this point, you're probably thinking, do we ever have horizontal stretches? Yeah, actually, and we could classify these as horizontal stretches in most cases. It's probably a little bit harder to do with algebraically, so I'm going to call them vertical stretches. It's just a matter of the way you compute it. But my vertical stretch, okay, so let's start at the origin, start counting. So to the right 1 and up 1, okay? So if I wanted to go to the other one, I'd go to the right 1 and I would go down, of course. So I'd go down 1, 2, 3. Okay, so my vertical stretch is on a scale of 3, so it's times 3. All right, 3 more on this, and we're just going to glance at them first and just see what happens. Let's just increase our vocabulary and increase our ability to just look and see. So started here, ended here. I shifted to the left, I shifted down, and it looks skinnier. So vertical stretch there. So let's just write that down. Horizontal shift of 1, 2, 3, 4, 5, 6 of -6. Vertical shift of 1, 2. Vertical shift of -2, and it's skinnier, so I know there's a vertical stretch as well. Vertical stretch. If it was wider, we could call it a vertical shrink. My tongue got tied right there. Sorry. The vertical stretch is a factor of, okay, well, let's go to the original. Over 1, up 1. All right, cool. Now we go to the one that's been translated, start at the origin. Over 1 and up 1, 2, 3, 4. So instead of going up 1, I went up 4. So I quadrupled it, so it's times 4. All right, let's look at this one. This is a cubic function, by the way, in case you needed to know that. It started at the origin, and then it shifted up to here. There is no stretch or shrink. I'll go ahead and tell you that. They actually are the same. And you can kind of tell by looking here and going right 1, up 1. And then you could go here and go right 1, up 1. You're still on the graph. So there's no stretch or shrink. But there is a horizontal shift, and there is a vertical shift. My horizontal shift is 1, 2 to the left, and my vertical shift is 1, 2, 3, 4 up. All right, one more, and I'll go ahead and tell you that this one does not have a vertical stretch on it either. But what I do have is some translating. So I'm going to translate it to the right. So it sounds like a horizontal shift of +2. So I went to the right 2. And then I went down 1, 2, 3, 4. So vertical shift -4. And then here's what else, and this is kind of cool. The original function, put down a paperweight real quick just so I can hold this thing in place. The original function looked kind of like that, right? But then my transform function slid and slid, but now it's not like that, it's like this. So since it basically went like this, it got reflected before we ever translated it. And so I'm not putting these in order, but it got reflected. There's a reflection over the y-axis. Okay, so we've looked at them, talked about what it does, And in the process of doing so, we've introduced some vocabulary. I do want to solidify that vocabulary just a little bit. So if we have, and I'm going to switch colors here just so it doesn't all run together, and it'll be here at the bottom. So if I have a horizontal or vertical shift, I'm going to call it a translation. And the shape does not change. If I have a reflection, then the shape does not change either. And if I have a, I'm going to go ahead and throw this word out here, a dilation, meaning that I've changed the shape, the size of it. And here I changed the size of it. This one was normal and this one was thinner. And so I've changed the size. These are, well, I'm not going to put them in any kind of category, but those are different. These are translations, and that's a reflection, and that's a dilation. And these first two preserve the shape. This last one does not. So when you hear me say translating, okay, I'm just sliding things around. When you hear me say transforming, then we're doing any of these things. So all of these things fall under the category of transformations. Terrible handwriting, isn't it?